Our last lesson in activity 32 is going to talk about circles and similarity. So what we're going to be doing today actually is describing and applying what is called a radian measure. So I'm going to start us off in our springboard book, page 470. Make sure you have something to write with, and you probably are going to want a calculator for today's notes. Okay, so I actually want to start us off with this question that I have underlined in red here, which says, Lance asks, are you sure that all circles are similar? So remember, similar figures have the same shape, but they are not congruent, okay? So they look the same, they just may have different sizes. Now, if it is true that any two circles are similar, can one circle be mapped onto the other? So they have this picture here with circle O and then circle P. They're saying, can we map one circle onto the other? Meaning, kind of this picture below, can we move circle O so that it's with circle P? Now, we've kind of looked at these before, this concentric circles, kind of that bullseye look, right? Okay, but the answer is, okay, that it is true. Okay, each circle can be mapped onto the other through a sequence of transformations. Now, if you remember transformations, those are reflections, rotations, translations, dilations. So if we look at circle O compared to how we move it into circle P, what transformations are being performed to map circle O onto circle P? Okay, well, it's a translation because the graph shifted, right? It moved to the right and up a little bit, it looks like. And it's a dilation because our circle O, if we want to map it onto circle P, we would just have to blow it up by a factor, right? So even though it's not a rigid motion because that dilation is changing the value of our radius here, they are still similar figures. Okay, so the point we're trying to make here on this first page, are you sure that all circles are similar? The answer to this is yes. Okay, all circles will be similar figures. Okay, so that actually is all we're going to cover on that part. So I want us to just jump to this page here, which I believe is on page 473. And we're going to talk about what's a radian measure. Now, remember on your calculators, okay, in our mode setting, okay, we have degree mode and radian mode. So radian is just another way to measure angles, okay, instead of degrees. It's a the radian measure. The reason we like radians is because it's an exact measurement. When we have degrees, sometimes we're rounding those answers. So a radian measure is just another way to measure an angle, okay, but it's more of an exact measurement, okay? So the way we can convert from degrees to radians or radians to degrees, it's actually pretty simple, just some quick multiplication in your calculators. But our first question here says convert 150 degrees to radians. So again, it's kind of like if we were converting from feet to centimeters. They're the same exact measurement, just different units. So here's how you do it for degree to radians. Basically, you just take your measurement that you're given, divide it by 180, and multiply by pi. Okay, so I would take, in this problem, we have 150, divide that by 180, times it by pi. Now, we're not going to have decimals for this. That's the whole reason of radians, is to get an exact answer. So really all you have to do is just simplify that fraction, and you can do it in your head or you can do it in your calculator. But if I did 150 divided by 180, if you hit math, see where it says frac? If you hit math, enter, enter, it'll reduce that fraction for you. So 180 or 150 over 180 reduces to 5/6. So that's why our answer here is 5 pi over 6. Now to do the reverse of that, to go from radians to degrees, because radian measure is good because of its exactness, but a lot of times that doesn't really help us figure out how big that angle is. We're more used to seeing things in terms of degree. So if we see a degree measure, we can kind of visualize how big that angle is. But all you're going to do is take your radian measure. So in this problem, it was pi over 5. And multiply it by 180 over pi. So what happens there is your pi's will cross simplify. And you just have to take 180 now over 5 to get your answer. Okay, so I'm going to do a couple with you, and then you guys are going to try some. So I'm going to do A and C. You guys are going to try B and C, or B and D. So in A, it says complete. So 20 degrees is how many radian? So I would take 20 degrees, so this is letter A, and multiply it by, take it over 180, and multiply that by pi. So all I have to do is reduce that fraction. Now I can do it in a calculator or cancel out the zeros. 2 over 18 would be 1 over 9 times pi. So our answer here would be pi over 9 radians. Okay, so I'm going to have you guys try the next one. What is 270 degrees in radians? Okay, if you did it correct, you should have got 3 pi over 2. And you can write this as 3/2 pi. It's the same idea. Okay, but that's how you do that problem. All right, one last one with me, and we're going to do letter C here. C says 2 pi over 3 radians is how many degrees? So remember, when we're going from radians to degrees, you just take your radian measure and multiply it by 180 over pi. So when we do that, the pi's should cancel. So I just have to do 2 times 180, which we know is 360. Divide that by 3. So our answer here should be 120 degrees. So you guys tried the last one. Try D. So pi over 9 radians is how many degrees? If you got it right, the answer was 20 degrees. Okay. So when we do more trig, okay, in the future or even in Algebra 2, you are going to do this a lot more, but knowing the difference between a radian measure and a degree measure. So just think of these little formulas here. You're either going to be multiplying by pi over 180 or 180 over pi. So it's very similar. You just have to figure out which one's kind of switched. Okay, but we'll practice this tomorrow together in class.